Welcome to this IBM Cloud Paks demo showing how organizations can quickly develop, build, deploy, promote, operate, and manage cloud-native applications, getting value to the end users quickly and efficiently. During this demo, we will showcase how IBM Cloud Pak for Applications enables teams to quickly make the necessary changes to an existing multi-container application, automating the creation of the new container image upon commit to version control. How IBM Cloud DevOps for IBM Cloud Pak orchestrates the release of software change in an audible and governed flow, capturing details of the deployments and ensuring quality across a series of environments en route to production. And how IBM Cloud Pak for multi-cloud management aids organizations in provisioning and managing cloud environments, along with providing monitoring capabilities to quickly triage and resolve incidents. To begin the demo, the business has asked the Mod Resorts team for an enhancement which they believe will boost website subscriptions and increase revenue. Working in IBM Cloud Pak for Applications, the developer includes the necessary code changes, adding new business logic to implement this new business request. When completed, the changes are committed and pushed to a version control repository. This is followed by a new container image being automatically built and registered in the trusted registry. First, the developer adds a call to invoke the getVisibilityData method. Upon saving the code change, the code is committed to version control, accompanied with a description of the change. The commit action automatically triggers a build process, provided in the code-ready pipeline, to create and register the new container image. From the Red Hat Container Platform dashboard, and while the build is executing, the developer can view the logs in flight and see that a new container image has been registered. With the code changes working as expected in the developer's inner loop environment, they announce that the code changes are ready for deployment across a series of environments en route to production. And to provide a more meaningful container tag making tracking of container image deployments easier, the developer calls a webhook which applies a version number tag instead of the cryptic tag automatically generated by the build process. With the container image tagged appropriately and available in the trusted registry, the team can begin deploying the new container image across the pipeline and verify application quality, checking to make sure the new feature works as expected. IBM Cloud DevOps for IBM Cloud Paks provides the DevOps capabilities enterprises need to successfully deliver new services and products quickly to the marketplace. In the continuous delivery part of the demonstration, IBM Cloud DevOps for IBM Cloud Paks is orchestrating the release of the new container image while providing governance for the automated deployments. And as Resorts is a multi-container application, IBM Cloud DevOps for IBM Cloud Paks makes it easy to coordinate the release of software change, making sure that containers which have been tested together are deployed together. Looking at the demo flow, we can see the change to the deployment files are imported from the version control system into the IBM Cloud DevOps repository. The release engineer then bundles these files as a collection or bill of materials, creating a snapshot capturing exactly which version of each YAML file was used in the deployment. Next, the release engineer kicks off the deployment process, pushing the YAML files to IBM Cloud Pak for multi-cloud management. As the YAML files are applied by IBM Cloud Pak for multi-cloud management, the correct container image is retrieved from the trusted registry and deployed as per the deployment specifications provided in the YAML files. So let's begin the release orchestration process. It is important to share that the value stream view displays what stage business value is currently at across the pipeline, along with where potential bottlenecks in the pipeline may exist. Bottlenecks which may be interrupting the flow of getting that business value from development to the end user. Switching to the pipeline view allows the release engineer, along with other team members, to see what containers make up the application, the latest version of each container image currently available in the trusted registry, and what version of each container image is currently deployed in the environments making up the delivery pipeline. With a new version of the Mod Resorts UI container ready to go, the release engineer starts the flow by deploying to the dev environment. As part of the release process, the release engineer is able to select which containers and the versions of those containers which should be included in the automated deployment. Navigating to the release plan, the release engineer can click through to view the automated deployment process steps in action. Watching the automated deployment process, the release engineer sees the apply YAML file steps, prereqs, IP, channel, subscription, app being sent to IBM Cloud Pak for multi-cloud management for processing. Next, a comment is added to the Mod Resorts UI event timeline in IBM Cloud Pak for multi-cloud management, sharing that a deployment has occurred along with the deployment outcome, pass or fail. This will go a long way in helping to triage incidents if any occur. And as this deployment is in the dev environment, a set of API tests are run to check application functionality. Returning to the pipeline view, the release engineer confirms that the deployment was successful and that version 1.1.0 of the container image has been deployed to the dev environment. IBM Cloud DevOps helps teams accelerate the pipeline by enabling the auto-promote capabilities between pipeline environments. For our demo, auto-promote has been enabled for dev to QA. This means that if a deployment is successful and the tests pass, the container image will be automatically deployed to QA, where additional application functionality and performance checks will be performed. With the latest versions of the container images tested together, they can now be deployed to production as a complete application. Same as before, the release engineer selects the container images to be included, and the deployment plan is run, deploying multiple container images to the production environment hosted on IBM Cloud. Turning to the IBM Cloud Pak for multi-cloud management user interface, the end user can see a topology view of the deployment including the cluster, subscription, placement rule, and application implemented using the specifications provided in the deployment YAML files. Team members can also verify the deployment in the Red Hat OpenShift Container Platform dashboard. Drilling down into Workloads Deployment View, the dashboard presents deployment details on the Kubernetes namespace, the container that is running in that namespace, and which version of the container image is currently active. And finally, browsing to the public URL, the team can verify that the new feature is now available to the end user. A quick check confirms that it is working as expected. As container images are created once for deployment anywhere, let's look at how teams can easily move a container image from one cloud provider to another. In this example, we will automate the move of the Mod Resorts UI container image from the IBM Cloud to AWS. Starting off in IBM Cloud DevOps for IBM Cloud Paks, the release engineer navigates to the Mod Resorts UI application environment view. Opening the production environment allows the release engineer to quickly modify the environment variable placement rule. Setting this environment variable to the desired cloud provider informs IBM Cloud Pak for multi-cloud management where that container image should be deployed. Treating the placement rule as an environment variable instead of a hard-coded value in the YAML file means that the deployment location, in this case AWS, can be dynamically set as a step in the automated deployment process. And with the placement rule set to AWS, the engineer kicks off the automated deployment. In reviewing the deployment steps for AWS, the release engineer sees that the prereqs YAML file is applied to set the policies for the cloud environment and to ensure that the enterprise security standards and regulatory compliance requirements are met. The apply of the image policy YAML file allows for the container image to be downloaded from a specific trusted registry. The channel file is applied to create the channel and declare the resources that can be deployed to that specific namespace. Applying the subscription YAML file sets the placement rule declaring what namespace the container image will be deployed to. And finally, applying the app YAML file creates the resources making the services available. Now, teams may choose a different naming standard for their YAML files or have fewer YAML files in comparison to this example. What is important is that the YAML files, regardless of the naming convention, contain the metadata and specifications for namespace, image policy, channel, subscription, placement rule, application, etc. The team can review the deployment outcome in Red Hat OpenShift Container Platform console to confirm the correct container version was deployed and that the service is active. And again, navigating to the Mod Resort site using a browser allows the teams to confirm that the application is available to the end user and working as expected. Continuing on in the demo, let's take a closer look at IBM Cloud Paks for multi-cloud management, and specifically the monitoring of services using the golden signals. The golden signals have become key indicators for SREs to effectively monitor distributed systems. These golden signals help with incident notification, assist in problem determination, and accelerate remediation. To set the stage for what is to be shown in the demo, The number of end users accessing this new functionality has exceeded expectations, so much so that end users are experiencing slow response times. We start with an alert notification sent to a Slack channel being monitored by the SREs. And while this demo only shows IBM Cloud Pak for multi-cloud management sending an alert, know that IBM Cloud Pak for Applications and IBM Cloud DevOps for IBM Cloud Paks share this ability. And through this automated notification, SREs can begin to triage the incidents for a speedy resolution. This is done by reviewing the golden signals to identify root cause of the issue, checking the event timeline to see if anything has changed causing abnormal behavior, drilling deeper into service dependencies to understand where the real problem lies, successfully identifying what the cause is, executing a runbook to resolve the issue, and verify that the system is recovering, followed by closing of the ticket. So let's begin by checking the golden signals. Working in the IBM Cloud Pak for multi-cloud management, the SRE reviews the incident details and sees that latency is rising with the mod resorts application. Expanding the incident, they note that it is a Kubernetes service being affected. Clicking the incident URL, the SRE is instantly taken to the Cloud Resources view for the mod resorts UI service and sees the golden signal monitors and the data for each. Hovering over the timeline entry, the SRE can see when the service started to display issues. Moving forward in our demo, let's remain triaging the incident until root cause is identified. Continuing to examine the timeline display and review the golden signal monitors, the SRE is getting more detail and suspects that the problem may not be with the mod resorts UI service, but wonders what might have happened previously which triggered this change in performance. Increasing the timeline view, the SRE sees more information shared by IBM Cloud DevOps regarding the new deployment, and that the deployment happened to occur at the same time where there was an increase in traffic and a decrease in the thread pool. Reviewing the IBM Cloud Pak for multi-cloud management service dependency view, the SRE sees that the mod resorts logic service is also presenting a warning. Reviewing the timeline for the mod resorts logic service, the SRE notices that a new version was deployed in conjunction with the mod resorts UI service. And at the time of deployment, end user traffic began to increase. Saturation levels started to rise. Root cause has been determined to be an issue with the mod resorts logic service, and armed with this knowledge, the SRE knows exactly what needs to be done to fix the problem. To resolve the issue, the SRE will begin by searching for an existing automated runbook which could fix this current issue. After executing the runbook, the SRE confirms that the application performance has already improved, and finally the incident ticket is closed. Starting off in the administration view for IBM Cloud Paks for multi-cloud management, the SRE navigates to the automation runbooks. A quick search on scale reveals that there's one automation runbook to increase the number of mod resorts logic pods, which has a high rating and a 100% success rate. The automated runbook is successfully executed, and the golden signals are showing speedy improvement. Traffic is rising, saturation is decreasing, and latency has returned to normal levels. As a final step, the SRE closes the ticket. To recap, using the golden signals, the SRE was able to pinpoint root cause of the issue and execute an automated runbook to fix the problem, minimizing impact to the business. IBM Cloud Pak for Applications, IBM Cloud DevOps for IBM Cloud Paks, and IBM Cloud Pak for multi-cloud management delivers an integrated solution enabling organizations with modern capabilities spanning the delivery pipeline from end to end, ideation to implementation and beyond. Thanks for watching.